in 1.6 you get a little bit of a continuation of some of the rules of the math and the properties that go with them. So 1.6 covers the commutative and associative properties, and this is on page 33 of your textbook. First, let's talk about the commutative property. But I'm going to begin on the right side of this table, and I'm going to say, well, what if 5 plus 6 is on the left side of an equation? Well, I know that that's 11, but we can add in any order we want, so I'm going to say that that is equivalent to 6 plus 5. So I've just reversed the order of 5 plus 6 and 6 plus 5, and that is completely fine for me to do. But it's not just addition. I can also say the same thing for multiplication. If I were to have numbers like 2 times 3, that would also be equal to 3 times 2. So you can multiply in any order, you can add in any order. So if I visit the words in this column, the words say the order in which you add or multiply does not change their sum or product. So it's basically saying the answer to an addition problem and the answer to a multiplication problem do not change if you do them in different order. So this is the words column. Here's a couple examples. Let's look at the symbolic abstract representation of both of these. For any numbers a and b, if I take a and add b, I can write that in the opposite order where it's b plus a. Also with multiplication, ab equals ba. That is the commutative property. Let's do the associative property next. And we'll again begin with just examples. I'll zoom in on this to make it more clear. If I have the quantity 2 plus 4 in parentheses, but then add 6, these parentheses really don't matter. The association between 2 and 4 doesn't matter. I can add up 4 and 6 over here in parentheses, and I'll get the same result. So it doesn't matter how we put those parentheses. Also, if I had 3 times 5 in parentheses, then times 4, that would be the same as 3 times 5 times 4. Now this is nice because, why would you ever want to do this? If I had 2 and 4 and I got 6, and then I had 6, yeah, I get 12. But sometimes it's nice to shuffle these around to look for things that pair up and give you 10 or 20, but basically numbers that end in 0, or maybe things that you can add up by 5s. Because here's 4 plus 6, which is 10, and another 2 is 12. Often you can avoid carrying and doing work like that. Similarly, 3 times 5 is 15, times 4 is 60. That's easy enough to do. But 5 times 4 is 20, times 3 is 60. And most people have an easier time shuffling that around as opposed to doing the work to where you'll have to carry or tax your working memory more. Symbolically, we can represent this as a plus b in parentheses plus c is no different from a plus b plus c, and a times b times c is no different from a times b c in parentheses. Make sure you've paused this and rewound to get that written down. But the associative property in words is the way you group 3 or more numbers when adding or multiplying does not change their sum or product. So let's see what this means as far as we apply it. The instructions for these problems say, evaluate each using properties of numbers. Name the property used in each step. Now the intent of these is to show that you understand why these are used. And I think that might be real clear in a moment. To rewrite this, I'm going to deal with these 1.5s. And I like how these 1.5s match up. Well, I also noticed that 1.1 and 0.4 will give me 1.5. So I'm going to first show that I'm rewriting these. Now don't think of these as 100% like order of operations problems. This is a little bit more about showing off your math skills, showing off your mental math skills. So here's 0.4, 1.1, and now I'm adding this to get 1.5 plus 1.5 plus 1.5. And then instead of adding this to get 3 and then 4.5, in my head I'm kind of picturing 15 times 3 is 45, and then putting the decimal there. So we've evaluated this. But the thing that we haven't done, we have not named the property in each step. For this step going from here to here, because we took the original problem, we've rewritten the problems in different orders. And since I moved this around a little bit more, I think I'm going to call this the commutative property. Now I don't want to move this and throw this off, so make sure that this is clear to you, how you label it. And going from 1.5 and all of that, I'm not going to bother describing the properties from the previous step. $35 plus 17 plus 5 plus 3. Here's 35. And I'm thinking, well, what would 5 pair nicely with? Well, this would give me 52 if I added them, and that's kind of ugly to deal with. This would give me 38, and that's fine, but maybe a little ugly to deal with. But 35 and 5 is a nice combo. So I'm going to combine 35 and 5. So I'm going to rewrite that, pairing those two up. Well, we've already dealt with these two numbers, so now I'm just looking at 17 and 3 with my eyes. I'm like, well, 17 and 3 is nice, because that ends up giving me 20, which ends in a 0. So 35 and 5 turns into 40. 17 and 3 turns into 20. And by doing it this way, I haven't really had to reach for my calculator, and I also haven't had to carry a lot of 52s, and then 5 would give me 57, and then 3 would give me 60. I get the same result, but it's a little bit more laborious putting in that work to get to the end result. And labeling this, again, I would just call this the commutative property. I'm more interested in seeing your mental math and seeing some of that footwork that you do, as opposed to being like, oh, okay, you know, this person can really label properties nicely. Okay, again, I'm looking for things that combine nicely. I see some fractions. So I can either deal with that now or later. Well, I think I'll deal with it, at the very end. So let's look at 8 first. 8 and 5 would give me 13, which I can add, but that's not so pretty. How about 8 and 12? Well, this 5 is just kind of sitting by him as lonesome, so maybe I just rewrite 5. But then 3/4 and 1/4. Well, if I had 3 parts of something and then they were all equal parts and I had 1 more, that would be 4 total. So that's going to end up working out nicely. So here's 3/4 plus 1/4. Now all this work likely gets done in your head as you move through these problems, like on an SAT or something, or some sort of test. But we still show the work because the purpose of this is to prove that you are repurposing these. And 3/4 and 1/4 give me 1. And then now I'm just going to add all this in one step, 26, and be done with it. Okay, I guess you could think of this as associative, you could think of it as commutative, however you want to do it. I'm going to call this commutative property. Okay, let's see. Let's make this next one an OYO problem. And we haven't done multiplication yet, but I don't think it'll be too crazy. So here's an OYO problem. See how you would partner these up. Because this was on your own, your answer may differ from mine. But 8 and 4, those partner up nicely because I will get 40. I'll get something that ends in a 0. And then maybe you did 40 times 2 next. No big deal. Then you would have gotten 80 times 3 is 240. But, you know, I like to combine things and limit my number of steps. So I did 2 times 3 to get 6. And I would call that the commutative property as well. A couple more problems. Let's see. Yeah, we'll make these class problems. Like, we'll do these in these notes together. So let's zoom in here. I have 2.9 times 4 times 10. Now, what you may remember from the previous section is that you can rewrite numbers using the distributive property. So first, I'm going to look and I'm going to see, well, okay, 2.9, gosh, that's really kind of ugly. And 4 times 10, well, that's working out pretty nicely. So I'm going to deal with 4 times 10 first, and I'll turn that into 40 in this step. That right there would be the, associative property or the commutative property. You can multiply the back end first. But then instead of seeing 2.9, I want to see 3 as some value I want to see 2.9 as some value altogether different. I know that multiplying by 20 is going to be ugly, so I'm going to take 2.9 and think of it as 3.0 minus 0 and 1/10. And the reason that I'll do this is when I do 40 times 3 through the distributive property, and actually let's not make that an optional step, show this distribution. 40 times 3 becomes 120, and 40 times 1/10 is 4. Now you might want to think of it this way. Well, 40 times 1 is 40, but then I got to move the decimal back 1. And then 120 minus 4 gives me 116. That's definitely more challenging, especially since it involved decimals. I probably won't freak out as much on that, and maybe on a quiz or something you'll have a problem that tells you to use the distributive property. So since we're tagging these, let's go ahead and label this as distributive property for practice and a reminder of what we just did there. Okay, make this one an OYO, see how well you do, and I'm going to put the answer up in about 5 seconds. So, I would just slash those out at the beginning because those cancel. 5 times 2 is nice because multiplying by powers of 10 is a more simple process. And then you get 250. If you did this slightly different, that's okay. But here is what I want to point out for a test. The instructions for these problems say, evaluate using the properties of numbers. You have to be able to use those using different properties of numbers. That means you should shuffle this around. So on an assessment, if those instructions are clear, then you should definitely rearrange something and communicate to the teacher that you were doing this a certain way. If you just end up doing this as a straight-up order of operations problem, then that means you did not follow the instructions and you kind of read through it too quickly or maybe didn't study well enough. So the point I'm making is this. As I zoom back out of this and remind you of what these directions say, it says use the properties of numbers. Again, if you just do an order of operations problem, you will not receive full credit for these types of problems. In the next video, we'll summarize some of these properties in one spot. No, actually, we're going to do that now. Okay, so this is a nice point of view for the properties of numbers. And the 3 columns say properties, addition, multiplication. So you can kind of see this all in one spot. To me, this is nice in how it's graphically organized. Commutative property goes left to right here. Associative, identity, well, A plus 0 is A times 1 is A. Well, and then we have the 0 property of multiplication, but it doesn't really work over here. I mean, it would kind of be redundant, right? So that's not happening there. And then we have the distributive property. Maybe you like the way this looks symbolically. Maybe you prefer it with numbers. And then lastly, substitution, where you just plug something in. And don't forget that in the previous section, if we had 10 plus 5, well, that's 15. And believe it or not, That's still substitution because you're replacing the quantity 10 plus 5 with 15. Okay, in the next video, we're going to do just a few expressions where they get simplified, and that'll be it.